All right, let's see how you did on normal model basics. Okay, so with our first problem, I want to make sure that you labeled this as your z-scores so we know what those numbers are. Okay, I did not do that. And then make sure you put the context label right here. This was about the highway miles per gallon that these vehicles got. And then I put those numbers in there based on a mean of 24.8 and a standard deviation of 6.2. Okay, then you want to put your percentages in there, okay, for those sections. All right, so then we can tell these were just some basic questions. And then once you have this established up here at the top correctly, you can answer these easily. So this one was the 68% between 18.6 and 31. More than 31, we added those together, and then that's 16% in that top part. About 13.5% were between 31 and 37. Okay, so that was interesting because it asked about 37 when our point here was at 37.2. So I guess I said about. And then describe the worst 2.5% of all cars. And so that would be those vehicles that get 12.4 miles per gallon or less. Okay, or less. So make sure you included that. All right. So here, the key to this is knowing that 95% is those two standard deviations. Okay. So, and so then that means it's symmetrical, and I can then add these two numbers together and find and divide by 2 and find their average. And then know that each direction is two standard deviations below that mean of 76. So I show my computing here. You find one of those changes. Okay, number 3 was about knowing that 51 to 64 was one standard deviation below the mean. So you can average it to find the middle, and then knowing one standard deviation below gives you that. All right, here was another one where you filled in the information. And so here is what your graph looks like. And here we have 85%. Because I added together the two sections. Of course, you could always do 100 minus the top 16%. Here is all but the top 2.5%. So that's 97.5. Here was that top 2.5%. This one was all but the bottom 2.5%. Okay, and here was just one of those sections, 13.5%. Here was those two sections together, and this was one standard deviation plus one more section. All right, and now here, we wanted to know, said how many standard deviations above or below the mean was a gala apple that weighs 7.5 ounces. Okay, so you know z-score is the number of standard deviations, and if it's positive, it's above the mean. If it's negative, it's below the mean. So here, I'm going to use my apple information. So I'm going to use the mean of 6 for the apples with a standard deviation of 1 for the apples. And it asked about a 7.5 ounce. So x minus the mean over the standard deviation is how we get 1.5 standard deviations above the mean because it's positive. Here, we use the information for our navel orange. For the navel orange, our mean was 7.5, and our standard deviation was 1.5. And they were asking about a navel orange that weighs 7 ounces. So that's the x value. So x minus the mean over the standard deviation is how we get negative 0.33. So that's 0.33 standard deviation. So a third of a standard deviation below the mean because it's negative. All right, so here, which one is larger compared to respective to its type of fruit? Okay, so comparing apples to apples and oranges to oranges, but then we're going to compare across each other. So here we go. Make sure you use the correct mean and standard deviation for those particular fruits. So here was my apple minus the apple mean over the standard deviation, and then the orange minus the orange mean over the its standard deviation. So the apple is larger respective to its type of fruit because it is more standard deviations above the mean than the orange. 2.5 standard deviations versus 1.67 standard deviations. All right, so here we go. We're going to compare apples to oranges here. And so we have these labeled here. Here's the z-scores, and then the context, the apples of the the ounces of the orange apples and the ounces of the oranges. Bleh. Ounces of the apples on the left, ounces of the oranges on the right. Okay, so it asked for these two particular areas, 5 to 7 on the apple, which I know is 68, and then from 7.5 to 10.5 for the oranges, and I know that that's 34 plus 13.5, so that's why that was 47.5. So I know that the apple is more common because 68% of apples are in that size range from 5 to 7 ounces. And the orange, that is between 7.5 and 10.5, is not as frequent. It's only 47.5% of the oranges are in that weight range from 7.5 to 10.5. Okay. More area under the curve, 68% for the apples in that area versus the 47.5% for the oranges. All right. That was your going over your first assignment in the normal model. Hope that helped.